Commonly, we refer to light as photons. Me back in 4th grade thought it was really cool to write photons are absorbed by chlorophyll during my biology exam. But what does photons really mean? To understand this, we'll have to dive into the theories and concepts of wave-particle duality. So let's dive into the world of quantum physics. Imagine you have a ball. When you throw it, what happens? Ignore air resistance. It travels in a straight path. That's what we expect a particle to be like. What if I told you that sometimes these particles portray wave properties too? Waves have what we call as displacement from mean point as it travels a certain distance, creating patterns and interference. In other words, they propagate energy through a medium. But when you take a very, very small particle, for example an electron, you will be surprised to see that they also behave like a wave. It is like an energetic wave and a lazy particle had a baby. This can be seen through a famous experiment known as the double slit experiment, which portrays wave-like properties of particles. In this experiment, they shine a beam of light through two closely spaced slits on a barrier. Behind the barrier, we see a pattern emerge on the screen. Unlike what you might have expected, that is, there to form two spots of light, we see a spectrum forming. This is called the interference pattern. When particles portray wave-like properties, they interfere between themselves, forming these patterns. But there is more to it. When scientists take a closer look at which slit the particles go through, the interference pattern disappears, as they see two distinct lines instead. This active observation causes a quantum phenomena called the quantum measurement that causes this change in pattern. Using this experiment, you could understand how a particle shows wave-like and particle-like properties. This is what we call as wave-particle duality. Wave-particle duality is a fundamental concept in quantum physics. Quantum physics is a study of very, very small particles and how they behave. To answer the initial question, photons is nothing but light, but when it acts as a particle. This wave-particle duality is what gives energy for photosynthesis, and it's of great importance. And that's what wave-particle duality is. Thank you for watching. I'm Dhakshesh Sivakesh from A Levels in India.